Hi guys, this is number 3. This is the work that we've been doing for most of the last week. Using the given information, you need to determine whether or not you can prove the set of triangles congruent. If so, you were asked to write a congruent statement for the triangles given and to state which triangle congruence criteria would support your answer. If you can't, then you need to explain why you cannot prove them congruent. So this is going to be an important question on the test because it goes to see how well can you justify your responses. All right, so in letter A, the first one, you see that you are given that angle QYX is congruent to angle QYZ, and that XY is congruent to ZY. So the very first thing that I would do is go ahead and set those markings or put those markings onto your picture. So you'll notice I'm kind of moving this out of the way. I went ahead and I labeled the two sides congruent, and then I labeled those two angles congruent. The second step, think about what else, based on the picture, not what you think, don't let your eyeballs fool you, but based on that picture, what else do you know? Well, you should already be thinking that QY is congruent to QY. That's the reflexive property. That's when it's congruent to itself. So again, I went ahead and I marked that. Once I've done that, it's really easy to look at the picture. If I'm looking at this picture, I can see that I have, yes, two congruent triangles by side angle side. So I go ahead and I just write out triangle QYX is congruent to triangle QYZ by SAS. And that is all I need to do. If you've shown your markings, if you've looked at the picture, and if you've written your congruent statement with the criteria that you used, you're good to go. The second one, in letter B, it gives us that angle B is congruent to angle E, that angle C is congruent to angle F, and that angle G is congruent to angle A. Well, let's go ahead and draw that in. When I do that, you will notice, let me get rid of that. You will notice that just by drawing in those three angles, what have I done? I have given not enough information because this is a set of equilateral triangles. However, no, these triangles are not necessarily congruent. Although the angles are congruent, the sides might not be. So for example, equilateral triangles, they might all have 60-degree angles, but their sides could be, although they would be in proportion, they are not congruent because not all the side lengths had to be the same. We could dilate those triangles larger or smaller, still be an equilateral triangle, but one could be easily larger than the other. So again, here's one of those things. I'm not letting my eyeballs fool me. Even though they look congruent, I can't prove congruency. All right, in the next one, in letter C, you were given that ABCD is a triangle. I'm sorry, it's a rectangle. And you're being asked, are those triangles congruent? So again, I'm going to mark what I know. Let's think about it. In a rectangle, you have opposite sides that are parallel and congruent. So I go through and I simply mark. My side lengths congruent. I mark the AC is congruent to AC because that's the second thing that I know. Although they didn't tell me that, I can see that it's a reflexive property. What else do I know about a rectangle? Well, I know that there are 4 right angles. So I went ahead and I marked that right angle in. So let's think about it. What do we have? We have HL theorem. We have, what are those 3 criteria to use hypotenuse leg? We must have matching hypotenuse, we must have 2 right angles, and we must have one of the legs that are congruent. And if you look at this picture, here's my leg, here's my right angle, here is my hypotenuse. So yes, triangle ABC is congruent to triangle CDA by HL. Now please remember, on any of these, as long as your letters are in the right format, you can still get this right. You didn't have to have the same exact triangle congruent statement as I did. You might have put CBA is congruent to ADC. You could have put BCA is congruent to DAC. However you did it will work as long as they're in the correct order. And finally, we learned that HF is the perpendicular bisector of EG and that HE is congruent to HG. So I went ahead and again, I marked it, HE congruent to HG. Since I know it's the perpendicular bisector, I went ahead and I marked it as a right angle because perpendicular bisector tells me there's a right angle. And the bisector part tells me that EF is congruent to FG. So you could go ahead and again, you could mark this as HL because you have a right angle, you have a hypotenuse, you also have a leg. But what else do we have? So in C and in D, if you think about it, there are different ways to prove it. In C, just going back for a second, if you had that BC was congruent to AD, and so you use side, 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 that is correct. That's another way to prove it. Here in this one, if I see that FH is congruent to FH by reflexive, then yes, I'm going to have side, side, side. So this time I wrote yes. Perpendicular bisector proves that EF is congruent to GF. So triangle HFE is congruent to triangle HFG by SSS. I could use the same reasoning and say that triangle HFE is congruent to triangle HFG by hypotenuse leg theorem. They both work. Both answers will be correct on your test. Good job. Move on to the next question.